Today's video, I will try to cover a little bit more on the exploratory data analysis and simple linear regression with stats model. Obviously, to write any Python code for machine learning, we have to import some of these packages. Uh, Now, the stats package is actually coming from this, so it's important. Otherwise, all these packages are important for today's work. The code and the data file, everything will be available on the GitHub location, so no need to worry. Basically, this is housing data, and if we see this data, obviously you can do df.head and you will get some information like this. Our main intention is using this file, using the simple linear regression, identify the price. Basically, using any feature and check what is the price. That's basically the simple linear regression. Now, one thing we can just observe, look, there is a date field, but which is not in a proper format. So definitely we have to work on it. There is another check we have to always do, that is df.datatypes. There also you can see this is a object data types, and obviously the machine learning models cannot handle the object data type. So we have to convert these things. This line I already mentioned, so no need to write once again. And then, as I mentioned, date is the categorical variable here. So what we are doing, we are simply extracting the year and the month from this particular feature and creating two more features. One is the sales year, another is the sales month. If we run it, it will provide sales month and sales year kind of information. Now, what is exploratory data analysis? Exploratory data analysis is all these things, and also just if there is a question like which month has most number of sales. From this, you can easily figure out that you can just do a group by in a sales month, and by count, you can find out what is the max month. Similarly, if we need the information about the minimum month, we can do that thing. This is the df.info command, which is very helpful to understand a lot of important informations about the data frame, like number of observations and number of features, what is the data types, number of null values. Just by seeing these things, we can see that there is no null values because all are matching with this count. If you want to understand a little bit of data, then this is a very good command which you can use, which will tell you like, okay, how the price is, what is the bedrooms. And this is important because then you have some idea that, okay, which is my kind of a categorical feature and which is the numerical feature. I'll describe about that, like what is the continuous variable, what is categorical variable in the later part. But high level, this is the thing. Now, the important thing is when we are creating the final data for any model training work, we should remove the unwanted features. Like in this case, I know the ID, which is basically just the number, which is not giving me any proper informations. Like these numbers are not really giving me any information. It's probably just a unique key or something. So I can drop these things. So what we are deciding that, okay, we'll drop this date. We know it's a categorical field and we have already created two other features from this. So we can drop that. Zip code is something which is not required for us. And then one of the reason is zip code can also be removed. It's a hard code to include to the linear regression model, and the location info is included in the longitude and latitude. Drop the feature ID, date, and zip code. So after dropping, you will get a fresh data, which has almost all the numerical features and is good. Now, the very interesting thing, especially when we are doing the simple linear regression, the correlation matrix is very handy. Why? Because, sorry, I think I have not run this, so let me run it. Yep, ID column now got dropped, and then I will run it one more time, and now the correlation matrix. What is correlation matrix? Correlation matrix is basically telling the relation between the features, and um, more positive value mean it's more positively correlated. And in this case, just by seeing this chart, we can tell that, okay, my square foot living value, sorry, it's square foot living, which is on the fourth, yes, square foot living is 0.7. So basically, it's highly correlated. As the square foot living is increasing, price is increasing. That's the basic philosophy also, right? In a house, if the square foot is more, obviously the price will be more. That's very understandable feature. But you have to be a little bit careful when you are working on multiple features, because here in this case, for example, the square foot living and next value is I think square foot above and grade, but it doesn't mean that these two are the next highly important feature. So for simple linear regression kind of a problem, correlation matrix is a very good tool to understand the overall relation. But when we are working on multilinear or with the multiple features, there should be a different technique. And I will explain that in the next video. Another very important and nice way to see the data is pair plot. Pair plot is giving the relation between the individual features. It should run, should not take this much of time, but it's giving this important and nice kind of a graph which is telling the relation between the different features like square foot living and probably bathrooms are very highly correlated. Something we have to check. Okay. Now the most important thing for today's work purpose, what we are doing, we are basically using the sklearn model selection process using the train test split. We are dividing the data into 80% and 20%, and then creating the X train, Y train, X test, and Y test. And price is our main label in this case. Now this is the main interesting part for today's lesson, that the stats model, because just by using this stats model and with this kind of code, you can easily find the relation between your labeled column by the important feature which we saw on the correlation matrix. And this will give you this nice presentation of different things, and I will go through all these things into the next video. But important thing is this one, this coefficient parameter, where the intercept and what is the square foot leaving. So this is my telling that y equal to mx plus c. So what is the slope and what is the intercept? And it's telling when 1 unit of x is increasing, how much y will increase. So this is very important feature. And also this is giving me the r squared value, which is a way to measure the performance of a model. Now just to understand like how individual features, like if we just run this, and this is something similar kind of thing we presented on the correlation matrix, that okay, square foot leaving was highly correlated, then grade was related to price, then square foot above was important thing. So this logic or this stats model is actually giving that correlation result with individual features. And this will give you a very nice picture to more thought, like okay, what are the features can be important, but again if they are related, then probably we have to find out that solution also. So today we'll conclude here, and then in the next session we will deep dive actually on this OLS regression results, and we'll try to understand how to basically interpret this regression results for linear regressions, simple linear regressions, and multilinear regressions. Thank you. If you like, please give a thumbs up and subscribe. Thank you. Bye.